Hi all. Welcome to my channel again. And today we will be talking about another sorting algorithm, uh, which is called as the quicksort. Sorry, my bad. That is called as quicksort. If you remember in the previous videos, we talked about bubble sorting and we discussed about the selection sort and the insertion sort, right? Uh, what is the quicksort algorithm, and how does this sorting algorithm basically differs from the bubble sort, insertion sort, or selection sort, right? See, basically, quicksort is a fast and efficient sorting algorithm, and basically it follows the divide and conquer strategy. So it works by picking one element as a pivot, then rearranging the array so that the element smaller than the pivot goes to the left, and the element greater than the pivot goes to the right. Then it recursively applies the same process and uh, the left and the right parts, right? Pick a pivot, then place it on the correct position and sort the left and the right parts, right? So that is how basically it works. We can go through the some of the big picture approach, and then through the one part of the code which we can understand it in one of the most basic ways, how the particular algorithm is working, right? So just give me a moment. Yeah. So before that, let's go to the picture, how to see how does it work. So basically, we have to determine a pivot, uh, and then we have to start with the pointers at the left and at the right. And basically we have to decide that if one number is less than uh, the another number, right? Let's say for the left pointer, right? So you'll have to shift the left pointer, right? So let's say 4 is less than 5. This is the pivot and we are comparing the left one. So once we compare that, we know that it's lower than that. 4 is less than 5, so basically we move the left pivot. Now since 2 is less than 5 again, then shift the left pointer towards the 6. Now since 6 is greater than 5, then we have to stop, right? Now we stay over there in the 6, and then we do the comparison between, since we know that the 9 is basically greater than 5, then we shift the right pointer. Now what we do is we do the comparison between 3 and 5. So now right pointer starts, right? And now once we do the comparison, we get the result that 3 is less than 5, which is true. So basically it is going to swap the left and the right variable. Now 3 is here and 6 is here, right? And then move the pointers one more stop, which is basically a pivot, right? And says 5 is equal to point, move pointers one more step, right? So now the left pivot has gone over here and the right pivot has gone over here, right? And this is how basically the quicksort algorithm will continue to work, right? So let's see it. There are some points that I have written. uh, so basically purpose is learning about the quicksort. uh, like sorting sounds simple, but what if I told you that algorithm can sort millions of element, and that is insane. So today we are talking about the quick sort, one of the fastest sorted algorithms. So what is the core idea, right? So this is the core idea, right? It's a divide and conquer algorithm, and it works by selecting a pivot, which you are talking about in the bigger picture approach. Now quick sort is a divide and conquer algorithm. It picks one element as a pivot, then it rearranges the array so that the smaller element can go to the uh, left of the pivot and larger one goes to the right. So step by step working, let's pick an array, right? And then let's say our array is 10 7 8 9 1 5, something like that, right? It could be anything. And then we pick a pivot. Usually the last element here, the pivot is 5. Now we move all the elements smaller than 5 to the left, and then the bigger ones to the right. After partitioning, the pivot is in its correct position, and we then apply the same process recursively to the left and right sub arrays, right? So the main part is the main intent over here is that the pivot gets fixed and the rest will get divided. Now quicksort is fast because it reduces the problem size very efficiently. Instead of comparing every element with every other element, it breaks the array into smaller parts, or you can say sub arrays, and sort them independently, right? So time and space complexity, if I talk in very simple language, in the average case scenario, the quicksort runs in O n log n time frame, but in the worst case scenario it will be O(n) square. In the real world usage, it's actually extremely fast, that you will recognize, once you write the uh, quicksort algorithm and compare it, with the algorithms like bubble sort, then you will find it out that it's very fast in practice, and it's also used in real system because it's a divide and conquer technique. The main drawback of the system is the worst case complexity, where the array are already sorted in nature, right? So that is where it won't be able to give you a lot of strength or efficiency, because the arrays would be more or less sorted, right? So basically, uh, when we should use quicksort, when we need the high performance and average case efficiency, and especially for the larger data sets, and that will be more or less the quicksort. So let's uh, let's do the code and try to understand it from the coding perspective, right? So let's start on that, right? So again, we will take an array, right? So that is the example usage. Array is equal to 10, 7, 8, 9, 1 and 5, right? And we will do sorted underscore array is equal to quick sort along with the array that we are going to pass as an argument. So that is what will be there, right? And then we will just simply print it, right? So I'm just writing it very simpler terms, right? Okay, now I create the function. So def quick sort array, and let's go for the base case where if the array has 0 and 1 element, it is already sorted. Okay, if the so that will be if length of the array is less than equal to 1, okay, then we return the array. And then what we are going to do is we will take a step 1. We will choose a pivot element, and right, so sorry, I put up at the rate, it's not that one, it's a hash. Here we choose the last element as pivot. So pivot is equal to, let's do that, I think that should also be good enough, is equal to array, and then it will be -1 to choose the last of the elements as the pivot, right? Then let's go to the step 2 and create 2 empty lists. So let's go ahead and create 2 empty lists, right? I will do left is equal to this and right is equal to this. Both are blank. So let's create these 2 sub arrays, elements smaller than pivot and elements smaller than pivot, and elements larger than larger than the pivot, right? So, and then what we are going to do is we are going to do the comparison of the element, and we are going to move the smaller elements towards the left side of the array and to the left subarray, and we are going to move the larger elements to the right side of the array. So that should be the approach, right? So I will do in the step 3 uh, right, compare each element except pivot. So we don't need to compare the pivot, but we can compare the elements with each other. So if I do for element, or for I will do for I in array, then we can do colon colon -1, like we're starting from sort of last. This is, as you know, it is start, stop, and step in the array. These are the 3 items, right? And if I is less than the pivot, and so left dot append and I, else it will be right dot append and I, right? So that is one. And then we do step 4, recursively apply the quick sort. So we recursively apply the quick sort and then we combine left plus pivot plus right, and then we combine left plus pivot plus right. So you can see we already have the pivot. So if we get the left array fulfilled, if we get the right array fulfilled, and then we join left plus right plus left plus pivot plus right, then we are going to get the array. So it will return quick sort left plus pivot, which is pivot, and plus quick sort right, and that's about it. I think we can try running this one. Let's check if this gives the valid result. So if it is 10 7 8 9 1 5, it should be something like 1 5 7 8 9 10, right? So go ahead and execute it. If there is some error, then probably we'll try to rectify that. Yeah, it's giving some error, so that's not good. We need to check what is the issue. Just give me one moment, I'll have this rectified. Okay. Okay, so let's go at the top. We did the sorted array quick sort underscore array, then we did the sorted array, we did quick sort. If length of array is less than equal to 1, then we return the array. Pivot is equal to array of -1. Yes, that's okay, that's looking fine. For element in array, sorry, my bad. For the comparison of each element except p1, for I in array, colon colon, sorry, my bad, I did a colon colon instead of a colon, sorry. So basically we are comparing each element except the pivot. Sorry, my bad, I put up an additional colon, and if I is less than pivot, then we are attaching the we are moving the smaller elements to the left array, moving smaller elements to the left array, and else we move it to the right side of array. So yeah, I think this should be fixed now. Let us run it once again. Yeah, so yeah, I was doing the stepwise approach, which is not right, because that was duplicating the values, and that was causing the issue and running the loop multiple times, and printing it, so which was sort of incorrect. So I did colon minus 1, right? So basically uh, so uh, the reason that we did array colon minus 1 is that it's sort of slicing, that it gives us all the elements except the last one, right? So so basically we are trying to do the appending over there, and if array is less than pivot, right? So basically pivot is your array minus 1, right? So that is the last element, uh, and the array is starting from the 0th element and is going to last but one element. So that is basically the way to go about it, right? So uh, I think we are more clear on this part, and um I think that currently the uh, way we took quicksort is okay. Uh, so if I talk about as I said that I did a colon colon minus 1 over here, and basically all the elements except the pivot we are trying to take over here, and the last element is chosen as the pivots, right? So basically the reason behind doing this comparison over here, instead of doing the double colon minus 1, which is colon minus 1, is that we should not compare the pivot with itself. So we need to exclude it, right? So that is how it is going to be, right? So if you want, I can give you a printed output. You can print it again and again, and then you can see that, right? So we can go ahead, and if you want to debug it, right, so that is the way of debugging it. You can print left, and then you can print right. A second, you can see what's happening inside the code, right, as well. So if we run it, yep, right, so you can see the left and the right array coming like this, like 10 7 8 9, and then it gets sort of that. So let's do it this way. I can do it left comma, then put up the left, then we can do right, then put up the right, and then we can run that again, right? So you can see that mostly the right arrow has been done like this, like it is 10 7 8 9, right? And then the left one has become like 7 8 and then 7. So this is how basically it's moving around the pivot, which basically I think is the last element, and that is 5. And once that is done, the items are returned quickly until unless sorry, recursively, until unless the complete array is sorted. And once it is sorted, it would look something like that, like it is 1 5 7 8 9 and 10, right? So that's all from my side. Yeah, before we go, right, so what is the difference between quick sort and insertion sort? uh, and if I say bubble sort and and the selection sort, right? So as you know that insertion sort, sorry, the quick sort is uh, the divide and conquer technique, and everything goes about the pivot, right? So that is a divide and conquer array using pivot and sorting recursively. Insertion sort, which we saw in the previous video, is inserting each element into its correct position. Selection sort is repeatedly, select the smallest element and place it correctly. And finally, the bubble sort, keep swapping adjacent elements until all of them are sorted, right? So that is the difference in all the sorts that we have gone through. And just do not want to drag the video any further. I will try to keep it short and simple. I think that I have covered most of the points discussed around the sorting, which we talked about, how it works, what is the pivot, and how do we divide it into subarrays, left, right, and right side, and then how we resolve them recursively. And so that is all from my side. I hope you like this video, and I will see you with another sorting algorithm, which is the merge sort, in the next video, right? So thanks for joining.